Hey, Pratik, are you there?
Yeah, I am.
All right, how's your day going for you?
Pretty good. We have a snow day today, but how are you?
Oh, doing pretty good.
Yeah, all right.
All right, tell me more about the class. How's that coming along for you?
It's going pretty well. We have a group-based test tomorrow and then a test on Friday. Sorry, Thursday.
So you have a group test tomorrow?
A group test. Yeah, it's like 16 points. It's harder questions. That's why it's with the group.
How does that work for a group test?
Basically, we all work together and we solve the problems, and it's like each person gets a copy of the sheet, but then we also get one like blue copy, which is like the final answer sheet, right?
Hmm.
Which is just another copy, but it's blue, so it's where all the work, like the final work and the final answers go. And so to get credit, um, each person must have their own work on it, right? They don't have to have the answer, they just have to have work showing that they tried the problem at least. It's just not one person dependent. And then obviously the answers have to be right on the blue sheet as well.
Okay, so as long as the answers are right, you pretty much get all the points then.
Right. Yeah.
Okay. Hey, yeah, that's pretty impressive. Sometimes I do group final exams on my upper level math classes, so
Yeah.
just kind of wondering how they do it over there.
Mm-hmm.
All right,
Yeah.
good. Well, tell me a little bit how the class is going then. You said it's going okay. I know we were talking about logarithms last time. How are you doing with those?
I mean, it's going, I think okay is the only way to describe it. I got a 91 on my last quiz, and then the quiz up, not my last, the quiz before my last quiz, and then my last quiz I got an 88, which isn't great. So,
Definitely bringing it up though.
oh, I hope so. Yeah, with the
Okay.
workshop and the test. Yeah.
Okay. Sounds good. All right. Now, let's see. I see you got some problems over here. Are these the ones you're currently struggling to really understand or?
Yeah, these are the ones I got wrong on my. So the two, three, and four are no. So two and three, one, two, and three are the ones I got wrong on my quiz, which I got a 91 on,
Mhm.
and four is a problem that I memorized from the quiz I got an 88 on to ask you because I haven't gotten that back yet. So, but I remember
Okay.
that this was a problem.
Yep. Sounds good. Okay. So I guess, oops, let me see. Let me just take a snapshot of this.
Mm-hmm.
Okay. So these are the ones you got wrong. Show me what you did.
Um, so I think I understand the. So I actually don't kind of know what I did. I said that number two, the log 16 to the fourth, I said that was undefined somehow because my work was I said log 2 to the fourth to the 1/4, right? If this was the base
Mhm.
to the fourth. And then I was like, I don't know how I would get 16 to be one. Like, what do you raise 16 to get 1/4? You can't because you'd be going back. So that's why I was really confused.
Okay. Now,
Because if I did 16 to the negative first, then I get um 1/16th. But if I did 16 to the negative second, I'd get. So like, what am I supposed to do?
okay, so from what I'm hearing, what you're saying is you're looking at this problem and you're trying to figure out what's going to happen over here. And this is much work that you're doing right here, right?
Yeah, I didn't like. I legitimately did not know what to do for that problem, so kind of got it
Okay.
wrong.
So here's what you're going to need to do next time. Whenever you see logarithms, go ahead and write out the definition. A logarithm base b x y definition states is going to be, you can say b for the base, raised to the power y equals x.
Yeah.
And remember that a logarithm is nothing more than the exponent. So if you were to start taking everything and changing it over into its exponential notation, we're going to have 16 for the base. You're going to have 1/4, which is going to correspond to this over here. And you're going to ask yourself, what value for y do you need? See,
That's
whenever
what
you,
I. Yeah.
good,
I
you did
actually do
that?
have that in my work. I had 16 question mark equals 1/4.
Good. As soon as you do it like this, it's going to unlock very quickly now. Because 4 squared is 16.
Mm-hmm.
Use properties of exponents. You can take it and you can recalibrate it. And over here, that's 4 to the minus 1. Equate your exponents and you're done. 2y equals -1, y equals -1/2.
4 to the 2y equals 4 to the -1. Okay, I see. Makes sense.
Okay, so you did this, but you got stuck right here.
Yeah, yeah, you're correct. So I saw that. I wrote down 16 to the question mark equals 1/4, and I was like, what could that question mark possibly be? So
Gotcha. So what you want to do here is just take it and just recalibrate it in terms of the base. That way it's going to fall out pretty quickly.
okay.
Why don't you do that now for number 3? See if you can recalibrate it.
Is it a similar problem?
It is.
That's probably why I got it wrong. 4 to the question mark equals 128. And then, so I say equals, so 2 times 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. So 2 to the 7th would be 128, I think.
That's exactly right.
So 2x equals 7. X equals 7/2. Yeah, that seems right.
How fast did that fall out now?
That makes sense, yeah.
Okay, so on your exam, just make sure that you take the logarithm and just recalibrate in terms of an exponential. Then it's a whole lot easier to understand. You can still do it in terms of a logarithm, but you see how you're doing a bunch of mental gymnastics to try to figure it out?
Yeah.
Yeah. Take it in terms of an exponent, so much easier.
Okay.
Okay. And let's take a look at your other problem you had here. It was question 4.
Mm-hmm.
Okay, so what was going on here?
I have no idea, quite frankly.
My suspicion is they want you to solve for x.
Yeah, yes.
Okay, so when you look at this, what's the first thing that makes you say, I don't know if I can do this?
It's got different bases.
Exactly. So what are you going to do to fix that problem?
I mean, what I noticed is that each base is the same. Or not the same, but like each base has the same, like you could 2 to the 3rd, 2 to the 4th, and 2, you could all make them base 2, but I don't know where to go from that.
What you want to do is use the change of base identity so that they're all the same. Now, you can use whatever base you want. I'm just going to say logarithm, natural log that is. And as soon as I do this, I overcome the complexities of a different base. Because now I just factor out the natural log of x, and I just have fractions. And also, look at this. 8 is 2 to what power?
2 to the 3rd,
16 is to what 2 to what power?
4.
And another property of logarithms dictates when you're powering it up, bring the power out front.
Right.
And then look what else you can do. You can factor out that natural log of 2, can't you?
Yeah.
So the real question is, what's a half plus a third plus a fourth?
2, 3, and 4 all have the same common base of 12. Yeah, multiple. So 6 twelfths plus 4 twelfths plus 3 twelfths, 13 twelfths, 1 and 1 12. 13 twelfths, I think.
13/12.
Yeah.
Keep, change, flip, or multiply reciprocal might be a little better option.
Mm-hmm.
And how many times does 4 go in 12?
Ooh, 3 times, so I could cancel that out. 1, 3.
And 3 and 19 gives me 57.
Mm-hmm.
13's prime, can't do anything with it.
Yeah.
Multiply both sides by the natural log of 2. And then if I want to figure out what the x value is, exponentiate and open that thing up. Using our property that stipulates exponentiate a logarithm by the base. And the other thing here is properties of exponents yet again. And I'll use the same property here. That's 2. There's my answer. Wow. There's a lot going on here. Let's go back to the very top.
Wait, how is it 57 or 15 over 13?
Okay. Sure. Let's talk about that here in a moment. Let's start at the very top though. And let's just kind of go through it step by step again. So the first thing that we acknowledge is they are a different base.
Yes.
So I have to ask myself, what am I going to do to overcome that problem? So whenever you see this, when you see something that looks a little strange to you, that's usually the dead giveaway. It says, look at me, what are you going to do about it? You say, what I'm going to do about it is I'm going to change the base up so I can overcome that obstacle of having a different base. So I use the change of base identity for all 3 of them. I fact out the natural log. And then from here, it's really just a matter of manipulation and using the observation that we have 8 and 16, which bases it 2. Now, they could have given you something else. Instead of saying 8, they could have said 11. And they could have said 27. And that would have been perfectly fine. You still be able to work the same problem. It's just going to be a little bit crazier because you're going to have natural logs floating around, but you can still do it. But because we do see that pattern, we want to capitalize on it, want to jump on it, and then use properties of logarithms, log 3 and the 4. Add up our fractions. 13 over 12. Multiply by the other side. And how many times is 4 again go in 12?
3.
And 3 times 19 is?
57.
And then for the next thing is, multiply both sides by the natural log of 2. Just like if you were to have x over 4 equals 5. Multiply both sides by 4 to solve for x.
Yeah.
I just consider natural log as a number. And it is. Natural log of 2 is a number. Then I exponentiate. But remember what happens when I have a product. I can take it and I can recalibrate it using properties of exponents. So that's what happened down here. But don't forget, if you exponentiate the natural log, the argument pops out.
Yeah.
And there it is. 2 to the power of, let's just say 57, a little backwards there, over 13. Okay, great problem. Does it make sense to you now?
For the most part, yes. Just trying to figure out one thing. Give me a second.
Sure thing.
So when we go down from this step where the yellow arrow like brings us down to x equals e raised to log natural of 2, right?
Mhm.
Um, why? Why? So 57 over 13 is multiplying to log natural or natural log
Mhm.
of 2, right? So why
Absolutely.
is exponentiating or why is it an exponent to e natural log of 2? Or is it like
Well, let's back up a few steps here. Okay, so I can say that. Exponentiate.
right? I get that.
Can you get that?
Yep.
Apply the property. You can say this if you want. You can say that. That's not helpful. You know what would be helpful? Put the natural log inside there. So I'm just using the multiplication property, the product property, instead of simplifying it. I'm essentially unsimplifying it. I'm going this way. Because by going that way, I can actually simplify further.
Oh, I see.
You see that now?
Mm-hmm.
Now, this is perfectly fine, but my suspicion is they want you to go all the way
Yeah, they do.
and simplify it like such.
Mm-hmm.
Good. Okay, does that make more sense?
Yep.
Good, good, good. Okay, did you have another problem you'd like to look at?
No, but do you have a problem that's similar to this one where it wouldn't be as easy because the bases aren't like you couldn't do 2 to the third, 2 to the fourth?
I can give you one.
Mm-hmm.
Okay, let me give you this one. Try that.
Mm-hmm. Mm. So how
Good.
would you
Combine your logarithms. How do you add fractions? Get a common.
denominator?
Let's do it.
So log of 3 times the log of 5, the log of 15. So log of 5 over log 15 plus and then 5 times 3. Did I do that wrong? I feel like I did that wrong.
No, you're doing fine. Well, yep, you're doing fine. Yeah, that's fine.
Okay.
Well, let me think about that. Wait me 1 second. Yeah, you did a little bit off there. It's not 15. This piece down here is log 3, log 5.
Oh, right. That makes sense. Um, so log 3, log 5,
That's right.
log 3, log 5. Okay, and then so it'd be log of x log 15 over log 3 log 5. And then we could say log 15 over log 3 log 5 equals to 2 over log x.
No, you went back up there. This is perfectly fine over here. But if you want to solve, let me ask you this.
Oh no, we need to get the x one, so we should leave that, but divide by it.
I wouldn't
17.
divide, I would multiply by the reciprocal.
Well, yeah.
Okay, keep going from there.
And then you have, wow, that's confusing.
What part's confusing?
How would you simplify the giant fraction on the right?
Well, it's going to take a little bit of maneuvering. The first thing that I could do is take that 2 and put on top of the 3, or I can put on top of the 5. It's really my choice. I'll just put on top of the 3. I'll say log 9 now.
Mhm.
And how am I going to unlock the x in the logarithm over here? What's my base?
10.
Power it up.
So x equals 10 to that giant fraction.
Yes, most certainly.
10 to the log 9 log 5 over log 15.
There's a few things you could do, more properties of exponents.
Mm-hmm.
You could take this and split it. You can say this if you wanted to. And that'll get you exponentiating by the base, get you the argument, log 5 over log 15. And that's what x is. And if you notice, this is really a change of base identity in disguise. So I can further state log 5 of base 15.
Is there any way to simplify that even further?
Nope, that's about it.
Okay.
Not much you can do here in this problem. Now, if this is something like 25 and that was 5, yeah, you probably can go a little further with it. But since it's 15, there's really not much you can do. Want to try another
So
one?
that would be negative 9 to the negative 1/2. It was if that if it was 25, it would be 9 to the
Mhm.
what could you raise 25 to get? 5.
Yeah, it'd be, then you say like the -2 and all that. Let me throw you another one here. Try that one.
Hmm.
Now, you have log 27. Is that a base or is that an argument? Just kind of curious.
That's an argument.
Okay, so let's make it a little
So,
bit more argument in a T, if that's a word.
okay.
I'll
All
bring it up
right.
like that.
Okay. All right.
Okay, go and keep going.
All right. Um,
Very good.
mhm. And so 1 plus a third equals 4/3. And then you would do
Mm, it doesn't really work like, well, yeah, but you're making it more convoluted.
Oh, wait, would it be log 3 and then 3/4 on the outside?
Put this on top.
Yeah, that's what yeah.
Then once there's a one from the logarithm, then go ahead and exponentiate. Kind of like that.
So would that get me here?
So you would have x, you would have 10 logarithm 3 to the 3/4.
Yeah, okay.
Now, there's really not much more you can do that's going to be of help, so that's probably a good place to stop. Well, you can take this, bring it down. And actually, one more thing you could do is you could say this, but not much more you can do here.
So it's x to 3 equals 3/4. 3 to the
Mhm.
3/4. Okay.
Because when you exponentiate a logarithm by its base, the argument pops out.
Okay, yep.
Okay, not bad. Let's try one more. Okay, so why can't you factor out a log x now? What's prohibiting you?
This right here,
Right.
because now it's log x over 2. So would I say like log x minus log over 2 over log over 3?
Minus x minus log 2. You got it. Use your quotient property now.
Mm-hmm. So that's eraser. Log x over log 2 minus
Very good. Okay. Get your logs together. Log of x. Distribute.
What do you mean?
Break your fraction apart. Okay, do you see that?
Yeah. And we're adding because we're distributing the -1, right?
That's exactly right.
Okay.
Okay, give you a
Um,
little more room there.
1 second.
That should say an x.
Yeah, that's what I was confused about. But you still can't factor out log of x. Would you subtract log 2 over log 3 to the other side?
Mm-hmm.
Oh, oh okay. Actually.
Okay, combine your fractions on the right now. And combine your fractions on the left. Good, good. And what about the right?
Hmm. Give me 1 sec. Is that right?
Let me see. Well, you don't need the log 2 on the right. All you need to do is get a common denominator. In log base or log 3, we'll do that.
Oh, yeah. My bad. Yep.
We're good. Keep going.
So, oh my God. Hmm. So log. That's confusing.
Add, subtract your numerators. So log 3 minus log 2.
Log 3 over 2.
Use properties. And use your difference property.
So log 3 over 2.
Mm-hmm. Okay.
Oh, okay.
Look at the right now.
So equals log 3/2 of log 3.
Simplify it.
Simplify what?
Go ahead and multiply both sides by reciprocal.
Yeah, that's what I was gonna do. Okay, yeah. So log of x equals log 3/2 log 3 times log 2 log 3 over log 3/2.
And what do you see there?
These cancel out. Then these cancel out.
So what's x?
X is equal to 2.
Yep, that's it.
That's cool.
Good. Do you see all those different properties you had to use in order to solve this problem?
Yep.
Yeah, kind of a lot going on.
Mm-hmm.
All right. Well, how are you feeling about the logarithms now?
Better. Yeah,
Okay.
that's good.
Now, besides these types of problems that you're working on at the moment, what other ones are you working on or are you exploring?
What do you mean by that?
Are you doing anything past logarithmic equations, or are you just focusing primarily on these here for the time being?
I mean, the whole chapter consists of graphing logs, properties.
Okay.
Oh, graphing exponents. The whole chapter is not only logs, it's also exponents. So like graphing properties of exponents, and then that kind of stuff.
Okay, so we talked about graphing before. Are you okay with it?
Exponential functions. Yeah, I think so.
How about graphing logarithm equations?
I think I'm good. I mean, you can give me a problem, I guess.
Okay, let me just throw you one here. Okay, what about that one? Can you do that one?
Yep. Give me 1 sec. Hmm. Okay, so if this is 0, 0, okay. If that's 0, 0, right? And then so we need a table. So 1/2, 1, and then 2. And then -1 times 3 equals -3. 0 times 3 equals 0, and then 1 times 3 equals 3. And then 1/2 plus 1 equals 3/2. 1 plus 1 equals 2, and then 2 plus 1 equals 3. And then -3 plus 2 equals -1, 0 plus 2 equals 2, and 3 plus 2 equals 5. And then you would graph those points of that 0, 0. Then you have 1, so 1.5. So right kind of there. That's horrible. Okay. Oh, but that is -1. So there. And then 2, 2 would be right there. And then 3, 5 would be right there. So kind of go like
And where's your axis at?
And then this would be my vertical asymptote of x equals 1. And then as x approaches 1, y approaches negative infinity. As x approaches infinity, y approaches infinity.
Mm-hmm. Yeah, I think you're probably okay with those.
Yep.
Where would you say most of the struggles you're having? Is there solving the equations, or it doesn't seem like just
Yeah, can we have some equation problems actually? Can we do that? I feel like that would help me.
okay. Let me see if I can pull up here.
Can I take the graph paper off?
Oh yeah, please.
Yeah.
Okay, well, let me just throw you this one. It's a little bit easier what we've been working on to just kind of go back with it. Can you solve for x?
Mm-hmm. Oh. Took this quadratic formula here. Can I not factor it?
If you can factor it, by all means do, because it's a whole lot faster than using the quadratic formula.
2, 8, 3, nothing, 4, 4, 5, nothing. I don't think you can factor it.
You sure?
Well, do I have the right equation to factor x squared minus 9 minus 16?
You power it up, and that's exactly what you do. 9 minus 16 is 25, or negative 9, negative 16 is negative 25. That's difference of squares.
Oh, hold on. I didn't combine. I was looking at it like, never mind. Never mind. Okay. So then it'd be x minus 5x plus 5x equals plus or minus 5. And then you would check. So 5 plus 3, 5 minus 3, both work. Minus 5 plus 3 is minus 2, which doesn't work, so x is equal to 5.
Yep. Okay, let's keep moving on. Let me throw you this one. Log base 2,
Uh-huh.
the natural log of x equals 3.
Oh, is that it?
Yeah, not too bad, huh? You're doing a great job on those.
Okay. Can you
So
give
see,
me
go ahead.
equation problems with like um when you change the base? Like I feel like change of base is really my weakest point right now. That's what that is.
Okay,
If you had to ask me like anything with change of base, then it's probably what I need to know.
let me think about some here then.
Oh, and maybe a couple of what are they called? Interest calculation problems as well.
Okay, give me a moment here then.
Mhm.
Here you go.
Shipping dot wrong. Where to start? Oh, but we know t. It's 1.
Okay, so let's back up a little bit. This right here is not really one of those interest problems. It is a population dynamics. And when you have population dynamic type of problems,
Mm-hmm.
you're going to have something like the initial population, and you're going to have something you're going to power up. And a lot of times you might see it in terms of E, like an
Mm-hmm.
R than a T. So it's kind of the formula we use for continuously compounding. It'd be
Yeah.
something along those lines. Now, what it would say is sometimes you might see it, it might look a little bit like this. This is getting a little bit into calculus ideas, talk about rates of change. So when we see population dynamics, you basically just want to start off with some kind of identity like this, and then consistently update as you go about your problem. So you have 500 ants in the cargo at the start of the voyage, and that's talking about this. So you would have
Mm-hmm.
500, and we'll have e to the RT. Okay, so 1 week into the voyage, there's going to be 800, and that's absolutely true. So 1 week into it. And what we're going to have here is, we'll say t is 1. Solve for r. Okay, skipped a few steps there. See if that makes sense.
Yeah. Log a to the 5th equals r. That makes sense.
Okay. Okay, so we're going to take our equation. We're going to update it. And we can utilize properties of exponents. And I'm going to skip a few steps again. I want to see if it makes sense to you. Right there.
Did you go back on the multiplication property?
I went back and started to put the t on top using the multiplication property for the exponents. That's exactly right.
Yep. Okay.
Okay. So there's my equation right there, which will model the situation. So when it be 1,000 or 10,000 ants on board, if I want to do part C, I'll go ahead and say equal to 10,000. And if I want to talk about when it's going to double in population, I take the initial and just make it double.
Yep.
Okay, good.
Wait.
All right. Go ahead.
Where did the E go?
Very good question. The multiplication principle.
Oh, I see. So because it's the same base, you can just say it's the argument.
Mhm.
Okay, cool.
Okay, let me throw you this last one here.
So in 1987, the population of Mexico was estimated at 82 million people. Um, 244. When will Mexico double its 1987 population? Oh, poop. Will the United States and Mexico have this? Oh,
Okay. How would you actually solve for t? Divide by 82. Now take the logarithm. Pull this out front. Natural log of e is 1. Solve for t now. Okay, does that make sense?
where'd you get log 2 from? I'm so confused.
How many times is 82 good in 164?
Twice.
Exactly. And what happens when you take the natural log of both sides?
Exponential. Actually, can I try the problem on my own, like from here? Because I got
Sure.
confused. Yeah.
Let me back up. Go for it.
That kind of threw me off. So, E 0.025 t equals 2, right? That's what you said. And so then you said log of 2 equals 0.025 t. And then you said t equals log 2. Oh,
Mhm.
okay, that makes sense. Yeah, yeah, sorry. I just kind of do it on my own to get it.
Not a problem.
Yeah.
What about for part B there?
So would you set the equations equal to each other? Is that
That's exactly it.
okay?
Okay, so why don't you go ahead and try that?
All right. So
There you go.
these are equal to each other, right? So if I take huh. Mm,
Try dividing by 82.
oh no, that's not it.
Yeah, just say 122 over 41. Nothing wrong with the fraction.
Yeah. And then you could say
No, I wouldn't take the logarithm yet.
something else I can do.
Divide over the exponential.
Divide over the exponential? What do you mean?
If I divide both sides by the exponential, Guess which property I'm about to use.
So confused.
Use the quotient property.
The quotient property. Wait, I'm confused. Can you show me what you mean?
Mm-hmm. Divide it over. And what do you do when you have the same base for your exponentials?
Oh, you subtract.
Let's subtract it then. .025, subtracted off 0.007, 0.018. Now take the natural log. Can you solve for t now?
Yeah, so wouldn't you just wait. 0.018 t. Okay, so t equals natural log of 122.41 divided by 0.018.
That's exactly right.
Could you multiply that 0.0118 to the fraction in the top somehow?
You could, I probably wouldn't write it like this. I probably just kind of push it off to the side, and I might write it like this to begin with. Or I also know that I could, if I want to write in terms of a fraction, I can write it more like that.
I
Just different
see.
ways of how I can write it. Good,
Gotcha. That makes
good,
sense.
perfect. Well, how do you feel about it all?
Better, yeah.
Okay. Well, let me drop you a few problems here so you can work on them later on.
Okay, that works.
Okay, there's another word problem. Here's some problems. We already worked one of them.
Okay.
And here is an investment problem. All right, Pratik, you feeling pretty good?
Yep.
All right, well, keep up the good work. If you need anything, let me know.
Thank you.
All right, have a great day.
You too. Bye.
Bye.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.